Every Ubiquiti's UNVR, Pro or not, has two ports. One RJ45 with 1 gigabit speed. The other one is SFP Plus with 10 gigabit support. I have been connecting both, each one to different VLANs, and they have been working fine. But you may know, in most cases, it doesn't really need 10 gigabits. So that's why I never know whether the SFP Plus port really support 10 gigabit. I never cared, but now I plan to repurpose some of my UNVR devices. So I really need to make sure the SFP Plus really support 10 gigabits network speed. So I did some measurements. To my surprise, I got very puzzling result back. So in this video, I will do some troubleshooting, try to understand what happened, and try to make sense of the weird testing results. Okay, let me get started. The exact same issues happen to multiple of my UNVR and UNVR Pro devices, and the symptoms are exactly the same. So in this video, I'm only going to use this lab environment UNVR Pro for the testing. And before showing you the issues, let me first SSH into the UNVR Pro to show you the current two parts. Okay, I'm in. First, show the IP address. See, I can see the two ports name already. The first one, VLAN 16 IP address. The second one, default network IP address. I can already guess which part is RJ45, which one is SFP Plus. But let's use the Ethernet tool to confirm that. So let me first show the first device, EMP0S1. Okay, the speed, gigabit, and it supports this type of link speed. So apparently this one is RJ45, right? Then show the second part. See this one, 10 gigabit. So this is for the SFP Plus. By the port names, EN for Ethernet, P for position, and these two parts, they are in the same position, P0, but two different interfaces. To get more information about the hardware, we can run ls PCI. So here it shows the two Ethernet controller. You can even see the company name. And the first one is for RJ45. The second one, SFP Plus. You can see their location information by running ls PCI TV. So it shows you the tree structure. You can see these two devices, they are under the same PCI bus. So far, we confirmed which part is RJ45, which part is SFP Plus. We also see from purely hardware perspective, they do support the advertised speed. Let me show you the current IP addresses again. Currently, the two parts, they are connecting to two different VLANs. In the right side, I have two client machines from each VLAN. Let me do some speed testing. I want to use iPerf3, but you know the UniFi OS doesn't come with iPerf3. It's not big deal because the UniFi OS is just a Debian 11 operating system. We can use the same Debian way to install new packets. In the SSH session, let me run apt update just to refresh the repository. Then let me install iPerf3. Installed. So we can validate it. We can run it. Okay, no problem. We are ready. Let me run iPerf3 in server mode in the UNVR Pro. Okay, it's running. Then let me show you the first example issue. In the diagram, I already noted down the IP addresses for the two parts. Currently, they have different subnet. Let me go to the first client machine. It is within default network, the same subnet as the 10 gigabit SFP Plus part. So let me run iPerf3 command in client mode, run against the IP address of the SFP Plus port. Pretty good speed, 10 gigabit. Then change to receiving direction. Also very good, 10 gigabit. I have no problem about the default network client at all. Then move on to the second client. which is within VLAN 16, the same subnet as the RJ45 part. Run the exact same iperf3 command. So basically, I'm visiting VLAN default from VLAN 16. Okay, run it. You see the first issue already. The speed is miserable, below 1 gigabit. Then run it in another direction, receiving the same thing, below 1 gigabit. So what happened? I specified the SFP plus part. Why I only got such bad performance? I suspect it must have something to do with routing. Let me check the trace route in the first client against the .2 subnet IP address. As expected, there's no hop. It's directly reachable because they are in the same subnet, right? Then move on to the second client. Okay, also as expected, because they are not in the same subnet, of course, some routing need to happen. First, it need to reach out to the gateway, and then the gateway will know how to route the traffic to the default network subnet. It's also expected, but compare these two routing results, the difference implies something happened in the path. To completely understand the routing, we need to go to the UNVR Pro. Let me show the route. See, this is very interesting. There are two default routes. You may know for Linux, the purpose of a default route is the last resort for the system to do routing. Only if the system doesn't know how to route based on other routing rules, this one will be effective. It will forward the packet to the gateway using the interface specified here. But see, the different thing for this UNVR Pro is it has two default routes. That's interesting. See, what's the difference? First difference, the gateway. Second difference, the interface. This is for the SFP plus interface. This is for the RJ45 interface. If the system decides to forward the packet to this gateway, it needs to use the fast interface. If forward to this gateway, it needs to use the slow interface. Then what's UniFi and what's underscore gateway? To easily understand it, let me run the route command again, but showing everything in number. Okay, now it's clearer. So the so-called default is just all zero destination. Now you see the IP address for the gateway. If the system need to forward the packet to the default network, it need to use the fast interface. If it's the VLAN 16 gateway, it use the slow RJ45 interface. So this difference between the two default routing rules lead to the different behavior in the two clients. By the way, if you use this highlighted 4 rules, you may have better understanding about the routing. For example, it says if you want to go to .2.subnet, you need to use the second part, SFP+. If you want to go to .16 subnet, you need to use the RJ45 part. In this video, I will keep using the default rules, but you know what I mean. Let's discuss what really happened. So for the first client, the one in default network, it ran iperf3 client. The ultimate goal is to reach out to the SFP plus part of the UNVR Pro, right? Because it's in the same VLAN as the SFP plus part, it will directly reach out to it, bypassing the router completely. Okay, once the traffic reaches the SFP plus part, internally within the UNVR, iperf3 server will serve the request. Once the iperf3 server responds back to the iperf3 client, it need to reply to the .2 subnet IP address, the default network IP address. See the routing table. According to the routing table, if UNVR needs to reach out to the default network, it needs to use the second part, which is the SFP part. That's why the packet will return through the SFP plus part. So let me say it again. The reply was through this part, not because the traffic came into this part in the first place. No, it's simply because this part has the same subnet as the client. According to the routing table, the system needs to use this part to do the return. Okay, that explains why it's fast. It's 10 gigabit because you see the two blue lines, they are both in 10 gigabit. Then let's see what happened in the second client. The client is in VLAN 16. The client need to reach out to the .2 subnet IP address for the SFP plus, right? Because they are not in the same subnet, the traffic need to first go through the router. The router has two gateway IP addresses for the VLAN 16 for the default network, right? VLAN 16 gateway receive the packet first. Then internally, it will be routed to default network. Then the router will route the packet to UNVR Pro to the SFP part directly because the router has the default network gateway and the SFP plus is in the default network, right? That's why we have this blue link. Now the traffic reaches UNVR, reaches to the SFP plus part. Then of course internally the IPv3 server need to serve the request, need to respond back. The request originally came from the .16 subnet. According to the routing table for UNVR Pro, if it needs to reach out to the gateway for .16 subnet, it needs to use the first part, which is the RJ45. Even though the traffic originally came from SFP+, the response will be routed through RJ45 due to this routing table. The IPv3 will send the reply back through RJ45, the slow part. That's why we have this green link back to the client. In the whole path, this final link is the weakest point. It slows down the whole traffic. That's why in the end, we only got lower than 1 gigabit speed. I know it's hard to believe, so let me use Wireshark to prove it. In the VLAN 16 client, let me launch Wireshark, start monitoring the 10 gigabit network. I already set filter, so I only want to see the communications between this client and the UNVR Pro. So then I go back to terminal. Let me restart the IPv3 server in UNVR Pro. Okay, started. Then from the VLAN 16 client, let me run the same IPv3 command, but this time only run it for 1 second, just to reduce the back and forth packet. Okay, started and it's done. So you see the speed is lower than 1 gigabit, right? Then let me go back to Wireshark. A lot of packets were captured, even we just ran it for 1 second. Let's examine a random packet. For example, this one from the UNVR Pro to this VLAN 16 client. Let me check the Ethernet section. Here we can find the MAC address for source and the destination, right? Because we are talking about this particular green link from the UNVR Pro back to VLAN 16, right? So I'm interested in the source. So see the source, the MAC address, it's this one. Right? This MAC address must be one of the two parts, either RJ45 or the SFP+. But which one exactly? To check that, I need to go back to the UNVR Pro's SSH session. Then let me run IP link. So here you can see the two parts, right? Then you can find their MAC address. So we can see the two MAC addresses are almost the same. The only difference is the very last digit. For the slow RJ45, it's D0. Then go back to our Wireshark, see what's the MAC address. It's D0. So the packet was returned from RJ45, even though from the IP protocol perspective, the IP address is .2.147. .2.147 is supposed to be the IP address for the SFP plus, right? But what the system does is it uses the RJ45 to return the packet, but from IP protocol level, it gives it the IP address of the SFP plus. Why is that? Because the original packet was received from the SFP plus. That's why here it's kind of confusing situation. IP address is the SFP plus port IP address, but MAC address is the RJ45 MAC address. The MAC address determines the real hardware. I hope now it's clear why for the VLAN 16 client situation, we have very bad network speed. Or depending on where the client is, you may get unexpected network speed. Okay, so now let's move on to next example issue. Let me show you next issue. So this time I unplugged the cables from both ports and I changed the connection to the RJ45 to default network. So going forward, the RJ45 and SFP Plus will be both within the default network. They will both have the .2.something IP address. But for this example 2, I will first plug in the SFP Plus cable. Once it's active, I will plug in the RJ45. So the sequence matters. Later you will see why. So now I already done the configuration change. In the SSH session, let me show you the current IP address. Okay, you can see we still have 2 ports active and they have the IP addresses indicated on the diagram, right? And then if we check the routing table, very strangely, here we still have 2 default routing rules. The difference is this time they have the same gateway. Then the only difference is the interface. So this kind of weird routing table will lead to the problem you see later. So now let me launch iPerf 3 in server mode. Okay, it's running. Then from the default network client, let me first test against the SFP Plus part. And this time, by default, it's in sending mode. I will send data from the client to the UNVR Pro. Run it. So 10 gigabit, right? No problem. Then change direction. This time, receiving mode. UNVR will send data to my client. Okay. Again, 10 gigabit, no problem. So when testing against the SFP Plus part, I don't see any issue. The issue is for the RJ45 part. Let me show you. Let me change the IP address. The 146 is the new IP address for RJ45. And this time, let me test the sending mode. Okay, lower than 1 gigabit, no problem. Then change direction. See? You see the problem, right? From the RJ45 part in receiving mode, all of a sudden I get 10 gigabit. You can see it's a bonus, but I do want to understand why. You know why? It's because of the routing table. Let me show you the routing table again. See, I prepared this diagram. When we test against the RJ45 part in sending mode, we don't see issue. Why? The client machine will send data to RJ45. In this case, the routing table in the UNVR Pro doesn't matter at all because there's no routing needed from the UNVR Pro, right? So the client will directly reach out to the RJ45. That's why I have the expected speed, which is 1 gigabit. But when I want to receive data from UNVR, so you see the UNVR need to send packet to the client, right? Let's check the routing table. This time the routing table matters because we have 2 default rules. The system will take the first one. And the first one says, okay, the system need to use the second part, which is the SFP Plus part. So that's why the system will use the fast part to send data to the client. We will end up with 10 gigabit speed. So just to save time, I won't show you the Wireshark capturing, but you can expect the result, right? Okay, then let's move on to the third example issue. Okay, the third issue. So this time I will still make the two parts in the same default network. So I keep the same .2 something IP address for both parts. But the difference, if you compare with the second issue, is this time I will plug in the RJ45 first. Once it's active, I will plug in the SFP plus. So you will see different behavior than the second example. Okay, I already reconfigured the system. Now let me show you the current IP address for the UNVR Pro. So the same parts, the same IP address, right? But the difference is in the routing table. See, this time we still have two default routing rule, but this time the first default rule is using the RJ45 part. Then let's see what's the different behavior. From the same default network client, let me test against the RJ45 part first. Against the .2.146 IP address in sending mode, I need to start iPerf3 server in the UNVR Pro. Okay, started. In the client, let me run the iPerf3 client again. I see 1 gigabit speed, no problem. Then change to receiving mode. Okay, again, no problem. So for RJ45, I'm okay. Then move on to SFP plus part. Run iPerf3 against the .2.147 IP address. First, the sending mode. Okay, I see 10 gigabit speed, no problem. Then change direction to receiving. Okay, now you see the issue, right? For the SFP plus part testing, when in receiving mode, I only see 1 gigabit speed. Apparently, the system is using the RJ45 to return back to my iPerf3 client. But why is that? This is the diagram. I plug in the RJ45 cable first, and then when testing against the SFP plus part IP address in sending mode, the client will send data to UNVR Pro. So in this case, the routing table in UNVR Pro doesn't matter. So that's why the client will directly reach out to the real SFP plus part. That's why we got the 10 gigabit speed in sending mode, right? But when we tested using receiving mode, the situation is different. Let me show you the routing table again, because the very first rule says, okay, we need to use the first part, which is the RJ45 part. The system used the RJ45 part to send data to the client because the client wanted to receive data, right? That's why we ended up with the green link, which only has 1 gigabit. So I believe this explains the third issue, right? You can see the messy situation, right? Depending on whether your two parts are in the same network or not, depending on from which network you run the client, you may get different speed. And if you configure the two parts in the same network, then depending on which cable you plug in first, you will see different result in receiving mode. In your situation, you may even find other scenarios, but in this video, I will only talk about these three examples. After realizing this very messy, very unexpected situation, I decide I will only use one part if I need the speed. But if I don't care about speed, if I do care about the capability for the two parts to connect to different network, I may still connect them, knowing I may have speed issue. Before ending this video, if you go to the UniFi Protect, then go to Control Plane. If you go to the console, you can see this setting screen, right? At the very bottom, you see the network setting. You will see no matter what's my situation, for some reason the system only shows one active part. And if you go to the dashboard, if you click the UNVR Pro icon, in the right side, you can find out the IP address and MAC address, right? You can see it also only give you the information for one part, even though now I know I have both parts active. This type of observations from UniFi front-end UI implies Ubiquiti only wants you to use one part. Of course, I don't have any official documentation to back up this type of guess. That's what I derive from this type of user interface design. Okay, anyway, in the future, if I do care about speed, I will only use one part just to have consistent expected result. Okay, this is a long video. Thanks for watching.